So in this series, we're going to take a look at many different algorithms, and we're going to start off with the one that we generally start off with, a pretty simple one, which is going to be merge sort. So this is going to be a recursive algorithm, and a lot of the algorithms we will see will be recursive. This means that somewhere inside of the algorithm, the steps that we need to follow, this function is going to call itself. It's going to say repeat the process on this smaller division of the data. It's not going to call it on the same division because then we would just go in an infinite loop and we would never end, and that is not something we want. It has to always be, progressing towards the end. It has to have an end, and each step through it needs to go closer to that end. So when we call merge sort again on a smaller piece of information, that piece of information has to be smaller. And you'll see what I mean right now. Let's go ahead and write this out right now. So we'll go ahead, we'll call it merge sort. And this is the name of it, obviously. I'm assuming you guys have seen some algorithms before. And in these brackets, we're going to put what our input is. So we're going to be inputting a bunch of numbers here. The first number will be x1, the second number will be x2, the third number will be x3, ... all the way to some number xn. So we're going to be inputting all these numbers. They could have any order whatsoever. So x1 could be 7, x2 could be 500, then x3 could be 3. So they're not ordered right now. We want to use merge sort to put them in order. The numerical values, we want them to be ordered. So right now, what happens if, what are the special situations that we can have, right? The ones that we can go ahead and say, if this condition is satisfied, we don't need to go through the whole process. It's just going to be a quick step or finished. Well, if we're only inputting one value, it's already going to be sorted. By definition, it's already sorted. If I just input the value 6, I can't order the value 6. It's already in order. That's the only value I have. So we're going to go ahead and write an if statement inside of the merge sort over here, and we can go ahead and say that if n is equal to 1. Now, what is n here? Well, n is going to be just the amount of values that we have inputted over here, right? We see we have x1, x2, x3. This has nothing to do with the numerical values that correspond to those. It's just the amount of values we're inputting. So if that value that we're inputting over here, n, is equal to 1, well, that means we're just inputting one value, and, well, there's not really much we need to do. So we are just going to go ahead and we are going to return x. Simple enough. If we just input the value of 10, that's the only value we input, n is equal to 1, so that means we can execute the code inside of that if statement, and we're just going to return that value of 10. That is your sorted data. It's just the data itself. Now, hopefully, most of the time we are using this, we are not going to just be doing that because that is pretty pointless. We are actually going to have many values, but in the event that we don't, we want to be able to catch it over here. And remember, this is a recursive algorithm. So that means it's going to keep going and it's going to keep dividing this up into smaller and smaller pieces, which means at some point you're going to have an end. So we're going to keep dividing up this information here until we have just one piece of information. For each time that we go through, we'll just have one piece. And that means it's just going to go ahead and return it because that means we are sorted. So that's one thing. You'll see what I mean in a moment over here. So we need a way out, and that is essentially going to be our way out. So now we're going to have an else statement over here, which means if we aren't entering here, we will enter down here, and we will go ahead and say that we will be returning merge square brackets over here, and we were going to call merge sort. And what are we going to call merge sort on? We're going to call the first one over here, we're going to call it on x1, which is going to be whatever the first value you put in over here. So whatever the first value is that we have, we are going to put that down here. And we want to call this on the first half of the data. So the first half, so we were going to call it from x1, and we're going to call that all the way to what is going to be the halfway value. The halfway value is simply going to be x, and we're going to have in here, we'll have n over 2. So that's going to be the value that we have, which is going to correspond to the half. So this is going to be the first half of the information, and we will go ahead and have another instance. So we're actually going to call it twice, call merge sort yet again. I'll make a little bit more space here. And we're going to call that on, well, now we already called n over 2. So we're going to go ahead and call that on sort x n over 2 plus 1 and all the way to xn, right? That will be the second half. So it's going to be calling it on the first half, and it will be calling it on the second half. And we're going to be merging those into one list, right? So this is calling merge. It's calling to put them together. And it's saying we will want to put together the merge sort of the first half and then the merge sort of the second half. So try to think of this is a little bit confusing right here, right? It's supposed to be confusing. It wants us to merge. Let's go ahead and annotate this a little bit here so we have a bit of information. It's telling us to return put together two lists. This says put together two lists, and the lists we have are call merge sort on the first half. I should probably not be writing that sideways. So let me go ahead and write it down here. Call merge sort on first half. And over here, call merge sort on the second half. So it is going to be putting them together. It's going to put the first half and the second half. Now, you have to think about how many times it's going to have to keep going through this and keep calling itself recursively until it stops, and then it will go and work its way all the way back up. So we can actually go ahead and, if we wanted to, we can go ahead and actually visualize this, right? Because it is confusing. The first time you look at this, it's very confusing. So let's go ahead and get some numbers over here. So we're going to go ahead and we are going to pick a bunch of numbers. So let's go ahead. We will take 18. We will take 7. We will take 2. We will take 5. We will take, what are some other values we want? We'll go with 12. We'll go with 2. We will go with 1. And then we'll go with 10. Okay, so we have those values, right? And if we want to think about this and correspond this to what we saw before, this over here is our x1, our x2, dot, 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 all the way over here. This is going to be xn. So that is how the values are inputted. This is not ordered in any way, right? 18, 7, 2, 5, 12, 2, 1, 10. We want this to be in an actual order. I actually realized I just have it 2 2s, and just to make things easy, I don't want to have that, so I will go ahead and I will replace this 2 over here. I'm going to put that to a 3. Okay, just to make sure it's not confusing. I don't want to have a repeat, not that it matters. So we have this set up over here. Now, what is our merge sort asking us to do? Let's go ahead and look at the algorithm again, right? What is this asking us to do? Well, is n equal to 1 here? Well, no, right? We clearly have 8 values over here, so n is equal to 8. So we're not going to be entering this right now. So we're just going to go down here instead to the else statement, and we're going to execute that code instead. And it's telling us over here that it wants us to have merge sort executed on the first half of information and the merge sort executed on the second half of the information. So let's go back down here. And what is the first half? Well, the first half is going to be these values over here, and the second half will be these values over here. So it's saying go ahead and separate those values. So we are going to do just that. So we'll take the first half over here, and we'll bring that down here, and we'll take the second half over here, and we'll bring that down there. Let's get back to the yellow. So we'll have 18, 7, 3, and 5, and this will be completely separated from 12, 2, 1, and 10. These are separated. They are completely individual over here. Now, what is it going to tell us to do, right? We haven't executed the merge over here, and we're going to do that later on. You'll see. But it says, is n equal to 1? Are we allowed to execute that return x right now? We can't, right? Just still, if we look at what we have over here, right? We go back to our lists. Do we have one value in these two individual lists that we're passing through? We don't. We still have 4 values. So that means we're going to go ahead and execute it again. We're running another recursive call, and we'll go ahead and we will split these lists once again. So this is going to be the first half of the first list, the second half of the second. So I can go ahead and I can put 8 and 7 over here. We will put 3 and 5 over here. And this will be the first half of the second list, so 12 and 2. And then you'll have the second half of the second list, 1 and 10. So now we have 4 individual lists. Once again, x is still not, or n is still not equal to 1 on these lists, so we will go ahead and we will repeat again. We will keep going. So that means we will go ahead and we are going to separate these once again. So I'm just going to go ahead and separate them here. So we'll have 18, 7, 3, 5, 12, 2, 1, 10. Now that looks like we just wasted a bunch of time, right? Because look, we literally just went and we took this and we split them up like that. Did we have to do that? What was to gain from doing that, right? It looks like we just wasted an absolute bunch of time, right? What was the point of that? Just a bunch of computing power wasted. But look at this over here, right? What is this over here? This is a sorted list. There's a ton of these, right? They're all over the place. Look, another one, another sorted list. Now you might be saying that's a ripoff, right? There's just one value there, but it's still a sorted list. Breaking all these values up into individual values has a purpose. We just created a bunch of sorted lists. And we are now going to use that merge function we saw before to work our way back up to create the sorted one. That was MergeSort, right? MergeSort breaks it down, and then as it merges them back together, it will sort them into order. So we'll now start off from the bottom over here, and we are going to work our way all the way back up. So essentially, since we want to have the lowest value first, so let's say the 1 here is eventually going to be the lowest value, and then 2, and then 3, and then the 5 we have. For these little pairs over here, we're going to start off by picking the smallest values of the pairs, right, when we start to assemble them again. We're still going to keep this whole order we have over here, but we're going to go ahead and make sure that the first value is going to be the lowest of the 2 as we start to work our way all the way back up to assemble this. Let's go ahead and try to leave them on screen over here. What is a color we haven't used yet? There's a lot of ugly colors. I'm going to use gray because, well, it's not really colorful. I want something light. I'll just go with blue here. So we have 18 and we have 7. What is the lowest value of the 2? Well, 7 is the lowest value. So we're going to go ahead and merge these together here. So these are going to be connected again, but we'll have 7 first this time and then 18. So these are together, but now this is going to be sorted. This is still a sorted list. We want to be absolutely sure that while we are assembling this again, we always have sorted lists. We merge and sort. They're going to happen at the same time. So we're merging and sorting at the same time, essentially, now that we have broken everything up. Well, let's go ahead and do it with this one over here. Well, we have a 3 and the 5, and those are already essentially sorted. So we'll put those right there, the 3 and the 5. So another sorted list. Over here, what do we have? We have the 12 and the 2. Let's go ahead and, I want my arrows here. Now we will have the 2 and the 12, once again, another sorted list. Everything seems to be working out pretty good so far. And then we have the 1 and the 10 over here. Those are essentially already done. And once again, another sorted list. So now we went from having 8 sorted lists to having 4 sorted lists. And we are going to repeat the process again. So what we're going to be doing is when we go ahead to make the next tier of lists, we are going to go ahead and make sure we keep picking the lowest value, right? So we might have to, reverse our little order around a bit, but we're going to keep picking the lowest value available. So we're going to go ahead and merge these over here. We'll start off, what is the lowest value? Well, that's going to be the 3. What will be the next lowest value? Well, that will be the 5, next 7, next 18. And look at that, now we have another sorted list. We'll do that over here. What is the lowest value? Well, now we have 1. Then next, we have the 2 from the other side over here. Then we have the 10, and then we have the 12. What do you know? You're gonna make me say it again, another sorted list. And now we're almost at the top. We are almost finished. We'll go ahead and do it again, and we'll combine both of them. First, we take the 1, then we take the 2, then we take the 3, then we take the 5, then we take the 7, then we take the 10, the 12, and then finally the 18, and we have our big sorted list. and we will have the big sorted list. Now I'm going to be continuing MergeSort in the next video. I don't want this one to run on too long, so make sure you watch that one. I will be starting off from right this point.